Welcome to This Explainer. I am absolutely thrilled you're here today because we are diving into a massive, frankly game-changing shift in the logistics and transportation world. Think about the last package you ordered online or the groceries you just bought. The massive supply chains delivering those goods rely entirely on commercial fleets. Now, for years, we've talked about electrifying those fleets as this kind of future goal to reduce emissions. But today, we're looking at how companies are actually conquering the single biggest hurdle to making that a reality right now.
Okay, let's dive into this. Today, we're going to break down this complex logistical puzzle. We'll hit on the real EV bottleneck, power that comes to you, scaling without the grid, AI and autonomous management, and finally, heavy-duty EVs in action.
So here's a crazy question to start us off. Why are modern, incredibly capable EV fleets just sitting idle? I mean, the vehicles themselves are fully ready to go. They're engineered for commercial use, they're reliable, and they are ready to work. But instead of being out on the routes, ensuring our supply chains keep moving, many of them are literally trapped in parking lots. Why? Because they are waiting on a 19th century power grid to catch up to a 21st century demand. It's a huge logistical nightmare. But as you'll see, the industry has found a really clever, almost rebellious way around it.
Section 1. The real EV bottleneck.
12 to 36. That is the number of months it currently takes just to secure a grid connection for commercial fleet charging. It's wild, right? If you're a fleet operator ready to deploy electric vehicles today, applying for a grid upgrade means you might not even have operational capacity for 1 to 3 years. Our electrical grid simply wasn't built to absorb fleet electrification, data center growth, and industrial reshoring all at the exact same time. The utilities are dealing with interconnection queues that run literally years deep, leaving businesses completely stranded.
And you know, the wait time isn't even the only hurdle. $100,000. That is routinely the cost to upgrade the infrastructure for just a single site. By the time you factor in the construction, the permitting, tearing up all that concrete, and the utility work, the capital expenditure is just staggering. And remember, that's just to get the site ready to plug a charger in. It's a massive barrier to entry.
We usually assume the barriers for heavy-duty electric trucks are things like range anxiety, maybe a lack of public charging, or those massive infrastructure costs we just talked about. But the reality, especially for heavy-duty yard operations, it's completely different. The vehicles have the range, the service networks exist. The real problem is purely infrastructure downtime. It's literally just the physical delay of getting power to the depot. The trucks are ready to roll, the pavement just isn't.
Moving right along to Section 2, power that comes to you.
There's a really beautiful reframing happening right now in the charging industry. The traditional model says, hey, build a station and bring the vehicles to the grid. But the mobile model flips that entirely on its head. Bring the grid to the vehicles. Instead of waiting around for permits and construction crews, companies are dispatching power directly to the depot or the satellite yard. The power comes right to where the vehicles already are.
The prime example here is BCharge EV. They provide 24/7 mobile grid-free charging across all 50 states. They recognized early on that power should never just sit still when the vehicles don't. Backed by $7 million in funding and some major partnerships with organizations like AAA, they are deploying mobile units nationwide. No grid reliance, no construction, and they completely bypass those massive wait times we just talked about.
Which brings us to Section 3, scaling without the grid.
Let's look at how fleet managers are actually doing this. SparkCharge outlines 5 concrete ways to cut EV fleet downtime. You deploy charging where the vehicles are, you stop waiting 18 months for grid upgrades, scale your capacity modularly, and utilize AI and autonomous monitoring. The craziest part? SparkCharge can deploy a mobile system in just 7 days. 7 days! So a fleet can be up and running while they wait for that permanent grid connection to finish years down the line. Now, what's really interesting about this slide is how it solves the scaling problem. You see, most operators start with a pilot, maybe 20 vehicles, and eventually they want to scale to, say, 150. Well, a grid-tied depot built for 50 vehicles becomes a massive bottleneck later on. But with a modular approach, you start with battery energy storage systems, or BEST units, for your flexible pilot stages. Then, as you grow into a large depot with a continuous need, you just scale up to power hub generation systems. It completely prevents the issue of stranded assets. Your infrastructure scales seamlessly right alongside your fleet.
And the financial side of this? It's an absolute game changer. It's called Charging as a Service, or CaaS. Basically, this converts charging infrastructure from a massive upfront capital decision, remember that $100,000 per site, into a totally predictable operating cost. Fleet operators just get a fixed per kilowatt-hour rate. There are no demand charge surprises from the utility company and no massive capital commitments to push past a board.
All right, on to Section 4, AI and Autonomous Management.
Now we have to talk about the invisible hero of the supply chain here. Because downtime isn't always a hardware failure, actually, a lot of times it's just plain inefficiency. SparkCharge uses Spark AI to analyze over 500 data points to generate custom infrastructure plans in under 60 seconds. It looks at your fleet mix, route patterns, depot layout, available power sources, even local climate conditions. By understanding exactly how a fleet operates, this AI reduces energy costs by 15 to 30% before a single vehicle is even plugged in.
And once it is plugged in, you get results that look exactly like this: 99.9% uptime. Think about it. The most expensive kind of downtime is the kind you don't see coming, a system that fails overnight, leaving trucks uncharged by morning. But by replacing reactive maintenance with 24/7 autonomous monitoring, issues are resolved remotely before they ever affect vehicle availability. Across over 400,000 charging sessions, this yields near-perfect reliability.
Let's move to Section 5, Heavy-Duty EVs in Action.
We've talked theory. Now let's look at the real-world proof. 96. That is a massive number. It represents a historic order of 96 electric terminal tractors placed by APM Terminals Elizabeth with Orange EV. This is one of the largest port electrification commitments in history. It proves that when the charging infrastructure and the vehicle technology finally align, major commercial operators are ready to dive in headfirst.
So the crucial point here is that these vehicles are absolutely not compromises. Take a look at the Orange EV Husk EXP. It can move an astonishing 180,000 pounds of combined weight packed with a 310 kilowatt-hour battery. And across their installed base, fleets are seeing an average of 97% uptime with over 33 million miles of real-world operation. These things are highly capable for the grueling demands of yard operations.
And this timeline at APM Terminals Pier 400 brilliantly illustrates the industry pattern we're seeing. Operators don't have to lead blindly. They started with a 20-truck rental pilot. Once the technology proved itself, that led to a 40-truck expansion, and then moved straight into a 60-truck standardized fleet. Companies are moving rapidly from tentative pilots directly into fleet-wide standardization.
And this shift is happening coast to coast. Greenwich Terminals in South Philadelphia recently executed a 24-truck deal, permanently retiring 10 of their older diesel-powered trucks. Electrification is no longer just a test phase, it's actively replacing diesel on a massive scale right now as we speak.
This all validates a massive paradigm shift. Kurt Nogins, the CEO of Orange EV, summed it up perfectly. He said, "This order is evidence of an inflection point in ports as operators move past the pilot and testing phase to standardize. The real-world data shows the business case for electrification and the environmental case align. Basically, when infrastructure isn't holding you back, the business case for EVs is totally undeniable."
Which leaves us with this final, thought-provoking question. If the power can literally come to you, if mobile charging networks can deploy in days, scale with your fleet, and manage your energy autonomously, what is stopping your fleet from going electric today? The grid is no longer a valid excuse to delay commercial electrification. The tools are here. Thank you so much for joining me for this explainer. I hope it sparks some exciting new ideas for you.